The camera's crooked again, but that's alright. Not going to worry about it. The package came in from Buzz for the coil. It came in today. This is Friday morning. So we're going to be working on Bob's radio here today. And I'm not going to videotape the installation of the coil because I need to have my face right on top of the connections. But I will show you as I go along the progress. Now Buzz sent me a DVD video file, data file, MP4 data, of him repairing the coil. So what I'm going to be doing is putting that on my video because he did not put this on his channel. I guess he put the coil in here, and I'll give you a closer look at the coil here. Halderson transformer. This is, I guess, the box that that something Buzz had, I guess, Halderson company. So he just put the coil in that. And we will give you a close-up of it. After he attached the coil wire to the top. Did a real nice job on it. Alright, let me get you on the tripod. Alright, now I don't know whether you're going to be able to see that good, or do I need a magnifying to help you out here. He did a real nice job on it, and I got my camera almost at a 90-degree angle here, and I'm afraid this mini tripod might tip over. I don't have my camera boom mount. I haven't used it in quite a while because this camera's too tall for that. You can see he put a piece of tape or something in here where the wire goes up underneath. Well, let me just do it without the magnifier. Let's just see if we can, you can see the wire, I can't even see that. Okay, the wire, he pulled it back a little and brought the wire up underneath and put some tape on there to insulate so it doesn't short out. And it was, geez, thanks Buzz, he cleaned out the terminals for me, which is something I was going to do myself. That saves me a lot of trouble. I won't have to tack the wires on because even though I got a desoldering tool, if there's wire on it wrapped around, I still can't clean them out good. So this is going to help a lot. So what I'm going to do, before I put that in, I want to measure the resistance of this coil so that I will know in the future, should this ever break again and need to replace it, I'll know what the DC resistance is of it. That's not going to help the inductance. But you know what? I think I'll measure the inductance of this coil with that Chinese inductance tester that I got. I'm going to do that also. I'm going to do that now before we do anything else on it. Now I got the... Oh, it was really hard for me to see with my eye lobe and everything to find out what two terminals of this coil is. It amazes me how people, can work on this tiny, tiny, tiny stuff. I would never be able to fix this coil if Buzz couldn't do it, and I'd have to give up. I appreciate Buzz doing this for me, so it just amazes me. Oh no! Oh no! I'm trying to measure the inductance and the terminal's loose. Hang on a minute. Hang on. We've got a problem. Hello there. How you doing today?
I'd like to welcome everybody to Old 64 Goats channel. He sent me the coil that had a broken wire on it. And here's the coil. As you can see here, it's broken. I can see the point where it broke off, so I think that's a pretty easy fix. But before I delve deep into this repair, I wanted to check the continuity on this other coil here. So let me just hook this up. Now this little tester here, it'll test this in resistance and microhenries. It's going to recognize this as an inductor. So let's see what it says. Alright, there you see 7.3 ohms and 0.22 either millihenries or microhenries. I forget right now, but at least we can document that coil. It's good. Okay, the old goat was talking about a nub, and I feel the nub right here. Let me just heat that up with a heat gun and try to melt the wax. I'm just gonna try to pull it here.
It's just like pulling off a Band-Aid.
I don't think it's gonna hurt to peel it back so we can hook it up over here. Alright, now I got enough length to solder it on here. I'd rather solder it on here than just to splice it. I'm just gonna see if I can burn the insulation off here. That's very, very thin wire. Alright, now I'm going to measure the coil here. Okay, I've connected the little meter to one end of the coil, and this is the other end that broke off. So let's just see if we get a reading on here.
Okay then, come on.
Come on, baby, you can do it. Come on. There we go. 51.8 ohms and 3.5 millihenries or microhenries. Here's where it should go, and they had this wire that broke loose from it over here. Just get rid of that. Now they had the wire going under here. This is that gimmick thing that just goes in here and goes inside. It's not connected to anything. I believe I should push it through there, just in case that has anything to do with it. So we'll just take the wire. It's easier said than done here. I'll just get the wire and stick it underneath, just like it was originally. Okay. There we go. I'm going to burn some more insulation off it. I'm going to wrap it around here.
Buzz, please don't screw this thing up.
Okay. Okay, I've got some flux here.
Clark, watch your language.
Just going to slop it on here. I've run into problems of soldering this type of wire. And then again, I've had other times where it was no problem.
You're full of it.
The flux usually does the trick. So let's see what happens here. Let's go for it.
You gotta do more than just try. You gotta do it.
Okay, goat, I got the coil finished. This is the one that had broken off. It's nicely soldered on there. But this one is potential problem. It was almost coming off, so I had to resolder it the point where it was coming off. So you got to be careful with this one here. When you solder a wire to that, don't hold the soldering iron too long. You don't want to melt the solder underneath. This might break off. Alright, let's test it one more time, and I'll box this up and send it to you in a little bit. I put a new battery in there because the other one was starting to flake out on me. So let's test this here one more time. 36.3 ohms at 3.5 millihenries. And we'll go on the other side and check that one, make sure that one's still working. 6.1 ohms at 0.22 millihenries. So, alright, I'm going to box this up later and send it on to you, Mr. Goat. Hope it works good.
I guess Buzz went to lunch. I don't see him anywhere. Hey, what's that? Oh, I know what that is. That's old 64 Goat's coil. Buzz is too stupid to fix that. I'm gonna have to do it for him. Oh my God, what have I done? I can't fix this. This is too hard. Buzz will kill me when he sees this. I better get out of Dodge fast. I hear him coming.
That was a pretty good lunch. I'll just box up that coil.
What the hell? Deckle! Deckle!
This thing broke. This thing came off. The rivet. And I didn't pull on it. All I had is the leads from my meter to measure the inductance. Now this would have come off if I had tried to solder my wire onto that anyways. Looks like we got a failure here. The wire is still on with it Buzz repaired and everything. It's still on the coil, but it's going to fall off. I put some Scotch tape across the coil here to keep this other wire from shorting out, and then I put another piece over. It looks like hell, but that's the best I can do. I don't know if you can see that. I can't. My eyes don't focus like that. It wasn't easy, but I think I got enough epoxy in there that it'll keep that. Now we got to let that set. This is supposed to be a 5-minute epoxy. The epoxy took like overnight to really set up good. It's supposed to be 5 minutes, but I may not have had to mix properly because on this here, it doesn't come out even at the end here. So today I made sure that they came out even, and I used this as a mixing. I've done a lot of mixing in this here. And I know it's pretty even now. So time will tell. And I got the coil sitting on the shelf. I had to put a second coat of epoxy on it because after an hour it was still tacky and the terminal moved. I used the Gorilla Glue brand 5-minute epoxy on the coil, and I've used this before and it takes a long time to set up. So I went and bought this here, the hardener and the epoxy, and mixed it in the right proportions, and that's what's on there now. Hopefully that will hold it. So I can't do anything more until that terminal is secured. As you can see, I used epoxy to hold this 8 microfarad 250 volt AC fan capacitor onto the chassis. There is no bracket on there, as I mentioned, and so this is the only way I could do it. Otherwise it'd be flopping around. I was going to take it and have the leads come down through the socket, which I'm still going to do, but I was going to have this thing standing there kind of like floating, but it was too close to the rectifier tube, and that wouldn't be good. So there isn't enough room under the chassis to mount it, so this is what we're doing. We got epoxy on there. We got a good amount on there on the whole bottom side. It says not to use it on 2 different kinds of plastics. I think polypropylene is one of them. I have no idea what kind of plastic this fan capacitor is made out of. It's made out of Chinese plastic. So I don't know. Hey, we're going to go with it. Not for use on polyethylene or polypropylene, as close as I could read that. Anyways, it's starting to harden up. It's only been a couple of minutes now. And, well, we'll find out. I just hope it doesn't eat through the capacitor casing. Now this is an 8 microfarad 250 volt AC fan capacitor that I got from China for $4.99. It took quite a long time to get here. So what I'm going to do is I'm going to run these wires here down through the keyway hole in the socket for the ballast and solder them on the vacant pins underneath the ballast, make the proper connections to the switch. So with this capacitor in series with the filament string replacing the ballast tube, you won't need a CL90, whereas if I was using this, I would have to put the CL90 in it and I wouldn't be able to go over 115 volts on this radio. But with this capacitor in here, I can push it up to just about almost 125 volts before the 25 volt filament starts going much over 26 volts. A volt or so over limit of a 25 volt tube is not too bad, but you try to keep it down at that level. As for the B+, I've already checked that with clip leads and everything and measured the B+ voltage with 120 volts going in, and I got about 142 on those 160 volt electrolytics. That's what they're rated for. So if anything, I'm going to have a little more B+ in this radio than probably what it originally was designed for, but that's not a problem. Alright, I got 115 volts going into the radio right now. The coil is not in yet. Across the number 43 output tube filament, I'm getting 21.25 volts. So it's a little low at 115. If I use this ballast here at 115, I have about 27, 28 volts on the filament. As you can see, the capacitor's in. I had to leave the leads a little long so I can work in there. With my poor eyesight, I need to do it that way. Temporarily, I got my meter across the filament of the 43 tube. And I'm getting 21.27 volts. That's at 115, which is the average, and some people have higher line voltage, so we'll push that up now. Well, alright, so let's say 119, okay. We've got 22.46 volts on the tube. So let's go to 125. All right, which we never get around here. At 125 volts, I'm getting 24.42 volts in here. So 24.3 volts, you know, thereabouts, okay? So the filament of the 43 is a 25 volt filament. So we're only, we're just shy of 25 volts. So we got no problem running this radio on 125 volts if we need to. Now, we're going to put a meter on the B+. These capacitors are 160 volt rated. That's just, I have to be very careful. My lead's slipping and I'm in trouble. Here we are at 152.1 on the input filter capacitor. 118 on the second capacitor as it goes through this 1000 ohm filter resistor right here. So we're safe, and that's at 125 volts, which we will not be running this. Now you're hearing a hum, a buzz, because the audio gain is open. We got no coil here. Okay? And we got that cardboard on the speaker, so it's giving it a buzzing sound. 144.5 volts. Remember, these caps are rated at 160. So 144. We're pretty good. We're pretty darn good. Now, I could put a CL90 in series with the input to the 25Z5 plate if I need to, but I don't think I have to. I'm not going to worry about that. Off camera, I'll check and see if these capacitors are running warm. They shouldn't be if they're good quality and they're under the rated voltage. As you could plainly see, we are running 145 volts, 144 to be exact. So there we are with the B+ on the input filter capacitor, 144.4 volts with 120 volts going in. The next step is to put the coil in. But I want to give that a good chance to dry, so we're going to come back on this video when this is hardened up enough so that I can put the coil back into the radio, and then the moment of truth. Well, guess what? We're going to try again now. The coil is hardened up. The repair here that I made is all ready. Now I got the numbers down that Buzz, the readings Buzz read off with his little Chinese meter. We're going to read the inductance. This will read capacitance and inductance. It won't read resistance, but that's all right. I'm curious to see what the inductance reads on this meter here on the coil. So if I can get it up into the upper right hand corner of the screen here, and on these two terminals here is what we want to be reading from. So let's clip on there and clip on here. This is the small coil and and we're reading 4.5 millihenries. So let's go to the next range and see what we get. Now that's over range, over limit. 4.5. So it's 4.5 millihenries on the little coil with the hair thin wire on it. Now, if I'm doing this correctly, let's see what the big coil reads. 0.41 millihenries. 0.41 on the big coil. Now, as you know with inductance, if you put an iron core inside the coil, in this case I'm reading the big coil right here, the inductance will go up. Here's a pair of pliers here. Watch the gauge. See that? That's the same thing as tuning an IF can or a tuning coil or anything else. Take the metal out and you're back down to an air inductor. In other words, has no iron in it. Just thought I'd just throw that in for what it's worth. Okay, now we got the inductance. Now let's check the resistance. All right, you're going to have to take my word for this because I want you to see the meter. We're going to take the resistance of the small coil first, which is going to be right here. And I may or may not get on the pins very carefully. The pin is solid now. .1 ohms on the small hair thin wire coil, the one that had to be repaired. All right, and the resistance on the big coil, if I can get these to stay on here, is 56 ohms. Okay, we're ready to put this in the radio. All right, I got the coil in, but as soon as I put the soldering iron on, and I didn't keep it on long, that lug loosened up a little bit. So I don't have much faith in epoxy at all. But it didn't come off, but it wasn't loose when I put it in. Now, I epoxied this at 11 o'clock on this video here when I had that big disaster, when that lug came off. I epoxied this at 11 o'clock this morning. It is now 6 o'clock. So the epoxy had plenty of time to set up. The moment of truth is here. Are you ready? Everybody got their fingers crossed, their toes crossed, their arms crossed, your legs crossed, and whatever else you want to cross. We're going to put power to it right now. Variac is on. Isolation transformer is on. And we're going to bring up the voltage to 118 volts. We're 118 volts now. Now this tube here, it tests good in the tube tester, the eye tube, but that only shows the emission. It doesn't show you the condition of the green display, and the green display is very, very faint on here. Here we go. Now we're getting static in there. I don't like that. Tubes are lighting normally. I don't know why I'm getting static in there. Only got about a 3-foot antenna wire on it. Why am I getting that static? I wasn't getting that before. Trimmer caps on the side here. Nothing. That figures. The iTube has got a very faint glow, but that's what it had before. Well, electrolytics are cold. I checked it after I pulled the power. All the resistors are tested, all done. That's weird. Turn down to the actually turning up to the high side of the dial, it cuts out. And the volume down. Touching the antenna wire here. Something coming in. Like an oscillator plopping in and out. Hear it? There's also AC there. On the 43 tube is not a heated to cathode short. I looked at my tube tester instructions and it's normal for a 25 volt tube on a 25 Z5 and a 43 and tubes like that to show a heated to cathode short when it doesn't exist. And if you still get the heated to cathode light lighting on the tube tester, when you drop the filament voltage down, then you do have a short. So that's right in the documentation. So I did that and it disappeared. So I do not have a heated to cathode short in the 43 output tube. These are hooked up right because I drew myself a little diagram here. We got the black wire here. We've got the what I say, the brown wire here, the other brown wire here, and then the green wire, which is right here. So there, it's correct, and the coil is in the correct way. There's the little screw symbol that I drew. So I didn't put the coil in upside down. That's the first thing I thought maybe that was doing it. Here's something interesting. Let's get some inductance in there. Nope, that don't do it. I'm doing the same thing here on the grid cap. Now I've been told this particular type of radio is the cheap version of the tuned RF. So if I go here, I've got two adjustments, and that's all there is on the tuning cap. Oscillator is plopping in and out. It's not a shorted cap. The oscillator is plopping out. Let's see, do I have another? Well, there is an adjustment here. I'm going to get my big head right in your way here, but... Very interesting. It's almost like a regenerative receiver. So this might be working, but it's very weird. Everything's sensitive on this. Alright, let me put a longer wire antenna on it. This made it worse. I'm just clipping it on some extra wire that I have it strung around on my old speaker wire, which is not going anywhere. It's just going around the other side of the shop here. We take this off and just let this hang on the floor here. More active. Geez, even turning the volume control changes it. This behaved just like a regenerative radio. Years ago, I built one out of a magazine using 1 or 2 tubes, I believe it was. Getting some music. Well, I'll tell you what, this is an experimental radio, Bob. You're going to have to experiment with this. I didn't realize it would be this bad. But, get the volume down. That's the only adjustments on here, these two on the tuning cap here. And there's no other adjustments on here. These coils aren't adjustable. You don't want to add anything on it. This is an antenna coupling cap. All this stuff has been changed. Well, I think that's all we can do on this. This is weak, but I wouldn't worry about it. And the only thing that's not going to be working is the pilot light. We got the correct voltages on the tube. We got the a good B+. I think that's it. If anybody's got any ideas out there, you know, fine. But otherwise, I think I'm done with it, Bob, as best I can do. There isn't any other adjustments on this. It's kind of a disappointment. Thanks for watching.